So let's recap a bit. We learned how to use Git locally to make commits, and just before the end of the session, we started with working on a separate branch to develop our feature, and then we merged it back into the main branch. And this was very easy, or there was not a lot going on, right, that we had to do. But this was because everything was fine and there were no what we call merge conflicts. So in this case, we edited some file and nobody did something else on the main branch in the meantime. So there was no chance that, for example, two people changed the same file in an incompatible way. So Git could just take the changes, combine them together, and everything was fine. If in the other case, somebody worked, your colleague changed something, and they edited the same file as you did, and even the same lines that you edited, Git cannot automatically decide what is the correct thing to do, right? It doesn't have an AI model internally that decides, okay, I'm going to combine it like this, or I like this person better, so their code goes in, right? So what you have to do is, before you push, or in general when you merge, is you have to resolve these conflicts in one way or another. And there is a very useful configuration option which helps you better understand the context of these conflicts, which is to enable 3 different versions of the software to you to judge the conflict. By default, you get only the version of the one branch and then the version of the other branch, and you have to somehow make them agree, merge them together. If you enable the option below, additionally, in the middle, you get a third option, and this is the version of the software before each of the branches diverged, right? So you have the original code in the middle, your version on the top, and the other version on the bottom, and then you can compare and decide what should go into the final commit. And you really just have to open your text editor, you have to remove these markers and leave the software in the state you want it to be. And then you add and commit, and this will do the merge commit then. If this was complicated to resolve, maybe write a better commit message than just merge, explain how you resolved the conflict. But in general, if it's straightforward, then also just leaving the merge default merge message is mostly fine. So we can maybe construct an example here. So let's say I start working on a new feature, git switch -c, I don't know. We can add a CLI argument for a command line tool to make it a bit better, maybe. So in the fib tool, we could do import sys, and then we can do something. If our Python script is executed as the main command line tool, not as a library, we do something like this. So n is the first argument we get, which will always be a string, so we have to convert it to an integer. And then we print fib n. What this does, I will show it again soon, is that you can run our command line tool like this now. So we don't have to import and then call the function and call the print, but we can just give the n on the command line, it will be used. That's maybe a nice thing to do. So let's add this. We can again look at the change. So git diff --, oh, that was wrong. Staged. So this is what we added now. We import sys, and then we add this magic here. This is a common Python pattern that this code that is below the if is only executed if you directly run the Python script and not if you import the fib function from this module. So this is a good thing to do for command line tools if you don't want it to run the code when you import the module. Okay, let's commit this. Add CLI. Okay, so now again our history changed. So we have a new branch, the CLI branch. It started from the main branch, but it's now one commit in front of this main branch. One more commit has been added. And now we can simulate a coworker. We go back to the main branch. And we edit the same lines in the file in a different way. So, for example, we could say we write a function that returns a list of Fibonacci numbers. Fib n for e in range n. Fib I for I in range n. Okay, you can also test this. And this gives us the 10 first Fibonacci numbers, which is also a nice functionality. So we do this directly on the main branch. So maybe it's my project, I directly commit to the main branch, but somebody else is working on the other branch. And now we are in a situation like before. So the main branch has one more commit than the last common ancestor, and the CLI branch also has one more commit than the last common ancestor, but we both added code to the bottom of the file. And to Git, this looks like the same line numbers, right? It's if you want to paste both codes into the same file, basically, you would have to overpaste the same line numbers. And this will mean that we can't just merge. So now if I did things correctly, if I now want to merge the CLI branch into my main branch, it should result in a commit, in a conflict, sorry. So it says it's trying to auto-merge fib.py, but it realized there's a conflict, a merge conflict in fib.py, and the automatic merge failed. And what this means is that we now have to fix manually these conflicts. And then once we have done this, we can add and commit, and then the merge will be done. So good thing to do is always to check git status. It says you're on branch main, and we are currently doing a merge. So you have unmerged past this. And the only thing that has a problem is this fib.py. And there's the untracked file we will get rid of soon, I promise. Git status -s also shows you this now here. So there's fib.py, and during a merge, it will show the files with conflict as UU, which means updated in both sides of the merge. And I have activated this option with the 3-base, this zdiff3, so I get 3 versions, which is trivial here now because the first version is the fibs function. Before there was nothing, so in between these middle delimiters here, there's just nothing. And at the bottom, there's the CLI. And now I just have to edit this file so that I like the end result. So for example, I could say, okay, I like the fibs function, and I like the CLI function, but the default CLI should be to use the new fibs function. So I took changes from one branch, I took changes from another branch, but I can also make a new change in this and resolve the merge commit like this. Or I could say the other one is just fine and we print the number, but maybe we want to do this. Or I could even do something like this for e in fibs and print e. So we print all of the numbers, right? So it doesn't really matter. You just need to have an end result of this merge you are happy with. You need to remove all of the special markers that Git inserted. And once you like the end result, you can commit. Okay, I think I like this. So instead of the nth number, we print n numbers. And now I have to add. Let's see. And now git diff staged is interesting because it's a merge commit. So you see the merge results in on main. I add the if name equals main, but with the different version I now edited. And because I did some non-trivial merge conflict resolution, I now add a comment maybe add CLI, but use it with the new fibs function. And then in the history, you can again see we combined the two branches. And because we successfully integrated this feature branch, we can now remove it. So git branch -d CLI, which again just makes the named identifier for this commit disappear, and we have merged the two branches.
So when a merge fails, you import the changes in the working directory, right?
Exactly. Yeah.
But with these weird lines,
Yeah.
and then you add as a normal commit.
Yes, so you open your editor, you need to resolve these delimiters, you need to remove them basically from all of the files. And once you're happy, you just add and commit and it's done.
But it's not that it gets in a weird state that you need to get out from.
It is. So if you, I don't know if I can, I mean, it's not a weird state, but it's the state of you are currently trying to merge and you haven't finished it. So this is when git status says you have unmerged paths, it means Git is currently in the state where a merge is ongoing and you need to finish it. What you can do if you say, oh God, panic, I didn't expect the merge commit, right? I don't want to work on this now, let's do it later. You can do git merge -- abort. And then you are back to the commit before we started the merge. Yeah.
If you want to abort your commit, but you want to keep the work you did and to prove the things happen on your branch and after to changes.
I mean, we are here in a situation where all of the changes are committed. They are just in different branches, right? And we merge. And if we abort the merge, we are in the situation before where the changes are committed, but we haven't merged them, right?
Yeah, but for example, you commit your branch on one file and say, well, not me. I just need to wait. I was supposed to wait for you to did it, and after to get back get your.
Okay. Yes. You can also do the merges in the other direction, right? So now I showed you work on a feature branch and you develop your feature and then something happens on the main branch. And in this situation, the maintainers of the software often ask you to first update your branch before we integrate again, because that, for example, means that the tests run on the most up-to-date version and not on your old version. And then you need to merge the other way around, right? You are on your feature branch, you update with git fetch, and you merge with the main branch into your branch. And we are talking a bit about this later, that there's a couple of different solutions to do this and how to do this with the forked repositories, for example, that comes in the next section. Okay, and this is usually the point where this applies, yes? So if you get these merge conflicts, that's the position where most people panic and then throw away and clone fresh. You don't have to do this. Yeah? Take a breath, look at these conflict markers. Sometimes it's hard to decide with more complex changes what is the correct solution to do, but maybe even talk to your colleague who did the other changes, sit together and look at what the correct conflict resolution is for these merge requests. Okay, and now finally, I promise you we get rid of this PyCache. So the general situation is there are many files on your system that are automatically generated, that are the compiled software, that the macOS Finder stores a screenshot of the directory in the metadata, that whatever, right? And you don't want these files to end up in your Git history. They are not important. They will be regenerated every time you do something, or they are just, or even they are security relevant. You use a software that needs some username or password to access a web service, a token, whatever. So you absolutely cannot publish your token to GitHub, because then everybody will be able to use your credentials and use this web service as you. And for these situations, you can tell Git that specific names of files or patterns of file names should always be ignored and never be added to the Git history. And the main example here for us in this Fibonacci is this stupid PyCache with the compiled Python bytecode that always shows up in the Git status, right? And if I would, which I haven't showed you, which many people do, right? Git add dot, just do add everything that we did in the local directory. It would add this thing, and maybe I do, right? So git status -s now tells me I added this CPython 3.9 cached bytecode compilation file to Git. And in this situation, what you do is you do git reset. That takes it back from the staging area to an untracked file. So now it's unknown to Git again. And we enter this PyCache directory into our git ignore file. So we open a file called git ignore, and we just say that we always want to ignore this PyCache. And if we now do git status, the PyCache is gone. We have a new file called .gitignore. And this we just commit and add to the repository because this will be the same for everyone, right? Everyone in the project, it's a Python project, everyone will produce these PyCache files, so it's fine to add it to the repository to share it with your other developers. Sorry, that was muscle memory. I haven't set up anything for pushing yet. So we added this rule in the git ignore, right? Just this one line. And this makes it that even though the PyCache is still here, it still exists, still there, Git doesn't care about it anymore. Git status is just empty. If I do git add dot, nothing changes because this PyCache file is not treated by Git anymore. I just said that these files are okay to add to the project because they should be the same for everyone using the project. But there are also files that are specific to your setup, to your machine, right? Maybe you use an editor that stores a configuration file. Maybe you have macOS that creates these .dsstore files in every directory you open with the Finder. And for this, you should not try to add those rules to every git ignore of every project you are using, but you can use a global git ignore in your user home, add rules there, and then they are ignored in all of your projects. Git can use the same git ignore in the project together with the system-wide git ignore or the user-wide git ignore. Together, the rules add up together, and then these files here, a couple of examples here that are system-specific, not project-specific. And these you can add then to your users' global git ignore. I can show you mine here for a second. Yeah, so these are project-specific compile commands. Is something for C++ projects. Debug, release, build are directories I usually use for the compiled software results. Files ending in .swp are specific to my editor. It's backup files created by my editor. So yes, yeah.
So it means if we have a global git ignore, we don't have to write a git ignore specific to our project.
You, in most cases, will have both. So you put in the project-specific git ignore, you put what is relevant to the project itself. So if it's written in Python, you add this PyCache and other things relevant to Python projects. And in the git ignore, in the global one, you add the things that are specific to your setup, your system, your operating system, your editor, things like that are not shared between all of the developers of the project.
In that case, won't it be a problem? As in, I have something in my global git ignore, and because it's in global git ignore, I forget to put that in my project-specific git ignore, and still when I'm doing the commit, it is referring to my global git ignore, and somebody who is cloning my project doesn't have that thing in there. I mean, it's not a big deal, but
no.
still.
Yeah, it's essentially making a conceptual mistake, right? You put something that should have been in the project git ignore in the global one, And that could lead another developer to by mistake add something, but then you see it hopefully in the code review that there was a file added that shouldn't have been added, and then you add the rule in the git ignore, I would say. I wouldn't worry too much about this. The project-specific git ignores tend to be very long because Python and C++ generate a whole bunch of files, and the global ones are usually very short. You have 1, 2, 3, 4 global rules for your operating system, for your editor, and then that's fine. And now we basically have everything for day-to-day work. So I think this was the point in time where I wanted to discuss a bit about limitations of Git. Git is very well suited for software development where the code is text files. So most of the operations is comparing lines in text files and rendering differences. It can't really deal with binary files. So large images, document formats like PDFs or Word documents. You won't get a good diff between version 1 of a Word document and version 2 of a Word document in Git because it's not a text file. It's completely opaque to Git. It can't compare the text in the one file to the other file. So that's something you need to keep in mind. Similarly, if you want to add data, binary data files to your Git repository, it usually can't well deal with this. And this will result in very large histories. Because if you update the data file, all Git can do is store every revision of it without a compression or without differences between revisions efficiently stored. It just stores really every single revision as the full file in the history. And this means that the repository size will grow very fast if you regularly update binary data files in your repository, which usually means use a separate data repository, download the data in a directory that's not tracked by Git and work on them. There are a couple of solutions for this. There's Git large file storage, which makes this a bit better, which I am not presenting here, but if you have this use case, Git LFS is a good idea in general. Or like I said, you have nowadays there's a couple of data management systems where you have also revisions for binary data files and you can reference them and have a script download the correct version of the data maybe and then have the analysis code run on it. And then there's also some things which are text files but which are also not great in the merge conflict resolution, for example. If you store a Jupyter notebook, it's a text file, it's JSON. You can read it, but merging the JSON, if you have a Jupyter notebook in a Git repository and you want to resolve a merge conflict, is really, really painful because you will have this complex JSON data structure, which technically is text, but really isn't simple text in the sense that you can just combine different lines and then it's fine. And there's some tooling, so there's NVDime and Review Notebook, which help you if you have a merge conflict on a notebook in a Git repository. You don't edit it in a text editor, but basically you get a Jupyter Notebook native diff in your browser. You can change the notebook so it makes sense again and commit the result after this. And my recommendation would be if you have notebooks in your Git repository, don't store them with the output inside of them. Always clear the outputs of the Jupyter Notebook before you store it in Git, which is a bit annoying if you want to present the results of an analysis to someone, but there I would point to the CI lecture tomorrow. What I would do is have the CI for a specific version build the Jupyter Notebook and push the result to your documentation and not have the fully rendered notebook itself in your code. Okay. Yeah.
And do you know any solution to store and versioning notebooks better than Git?
Yes, so these two tools are great, I mentioned, right? Then you can just keep the notebook and you just have, if a merge conflict occurs, you have to use these tools to resolve the merge conflict. And after you did this, you can commit them. There's also a project called JupyText, I think, And this changes the format of the notebooks to basically be a normal Python script with special comments for starting a new box or starting a documentation section. And this is much better suited for then merging with Git. It's not the JSON data format that Jupyter uses by default, but it's a different format that also renders as a notebook and that you can use. And then, yeah. This is a well-known shortcoming of the Jupyter notebook data structure they use for storing the notebooks. And there's these tooling around this format, and there's alternative formats for storing notebooks.
I guess there is Marino, which is something that is a sort of notebook, but it's a Python script, I guess. So Marino thinks to be also well suited for this kind of situation.
Yeah, I know the project. I haven't used it myself. To be honest, it advertises itself as the new notebook, so to say. I can see that it really hasn't taken a large market share, but it certainly seems to work nicely and address a couple of the pain points with notebooks. So I think it's a good approach. Yeah. There was a question in the back, or?
Just if you can repeat the name of the tool.
Okay. Yeah, so it's, I mean, the slides are online, right? It's these tools here, NBDime and Review NB. You can look them up. Yeah, okay, so this is just a small overview slide for you to check later, right? The Git state machine, so to say, working directory, staging history, and the remote, and how you update, and the most used command to update is git pull, which is a shortcut in this state machine, which gives you something from the remote directly into the working directory. Okay, this was where I thought I would be before the lunch break. I think we can continue if there's no questions now. Okay. So we talked a lot about working locally, but now we want to introduce really the server side of things, where you can push your changes, collaborate with other people, the Git hosting providers, these software forges. And they are all basically similar. Different products, different services, but very similar features. So they all have the basic functionality that you can upload a Git repository, you can push and pull. And then around this functionality of having a server with a Git repository, which you can even do on your own normal HTTP web server, you can teach Git to talk to your own server. You have functionality around the software development workflow that should help you develop software. Just before the break, there was a question on how to avoid duplicate work, right? I do something, my colleague does something similar, and we end up wasting some hours of time because we worked on the same thing. And this is basically the feature set that help you do these kind of project management things. Issue trackers allow you to say, open issue, describe what you want to do, and say, you do this, I do this, you plan how this is done. Then this whole business about merging changes into the main branch is let's say, decorated around. So there's the concept of pull requests or merge requests in GitLab lingo, which means that you work on your branch and then you propose that this branch is merged into the main branch, and it renders the diff, and the maintainers can comment and exchange and say, please change this or do this, and it displays the result of the unit tests and so on. There can be wikis, there can be project management. You can have nice pages about your software releases and the tech versions of your software. And these are very similar amongst all of the providers, I would say. I took 3 here, for example. There are a couple more. You by now all know GitHub, because that's where we host the repositories for this school. This is by far the largest hoster. It was acquired a couple of years ago by Microsoft, so now belongs to Microsoft. Many of the open source projects are developed on GitHub. We already saw the Linux kernel on GitHub, which is technically not developed on GitHub. It still uses email to send around patches and merge requests, but the result is published on GitHub. But projects that are really developed on GitHub with pull requests on GitHub are, for example, the Python language itself moved a couple of years ago from their own solution to GitHub and using Git. All of the major libraries we are using, NumPy, SciPy, Matplotlib, they are developed on GitHub in public repositories there where you can contribute. As a private individual, you go there, you make an account, and what this gives you is an unlimited number of public and private repositories for free. You get the CI service for free for public repositories. You have to pay if you want a CI for your private repositories. I think for students there are some free CI minutes, so you can apply for a student discount, and then you get, while you are a student, you get free CI server minutes. GitHub itself, the software they use, is not open source. So the whole open source world basically is working on GitHub, but the web interface and the code below that actually operates GitHub is not open source. And that's the main selling point of GitLab. So GitLab itself, the software, that the web service is open source, at least with an open core community edition. They have a paid professional edition that has more features than the open source edition. And also with GitLab, you have the official instance at gitlab.com, but because it's open source, you can also install it on your own servers and run your own instance of GitLab in your institutes. Maybe some of your institutes have a GitLab where you can host your own projects. For example, CTAO has the GitLab at gitlab.ctaobservatory.org. And then a third option, which is fully open source based on the technology called ForgeJo, which is Codeberg, and it's run by a German non-profit organization. It gained some traction after GitLab started pushing more and more features to this paid version of the software, and Microsoft bought GitHub. I have in my home, I have a little computer that's running ForgeJo, where I have my own private repositories, so my own in my VPN, my own Git server. Very easy to deploy, very lightweight, can run on a Raspberry Pi, for example, in your home. You have your own Git Forge. And then the question is, how does Git communicate with these servers? And there's basically two options. One is the standard web protocol you are all used to. So you, as you go with your browser to GitHub, also the Git command line tool can use HTTPS to communicate with GitHub. But since a couple of years, this only works for reading. So for unauthenticated requests, you can download, you can clone the repos. But if you want to really do something with your user that requires write access, so you want to push or resolve a merge conflict or something like this, you can't just log in with your username and password. You have to either generate a special token in the GitHub UI and configure this, or you have to use GitHub's own command line tool to log in, and then it creates this token automatically for you. This is a bit more cumbersome, but still just works. Let's say is using the SSH protocol, which is based not on symmetric cryptography, so a password that you and GitHub know and can compare, but it works by asymmetric cryptography, which means you, on your machine, you create a pair of a private and public secret keys. And how this works is that the public key can be used to encrypt something, and only the private key can be used to decrypt. And you keep the private key with you, and you tell everyone in the world, including GitHub, that the public key is your public key. And then to prove that you are actually yourself, GitHub will encrypt something, secret information, with the public key, and only you, because you have the private key, are able to decrypt it. You decrypt it, you tell GitHub, hey, this is what I decrypted, and then GitHub knows it's actually you, or at least the person owning this secret key. And there's a couple of technologies that come with most operating systems that you protect also the secret key with a password, but you only need to enter this password once per login session, and then it's cached, the decrypted key. And this works very nicely, and I would recommend setting this up. And this is how you can do it. So you have to add at least one public key to your profile. And again, it's best practice to not use the same private key everywhere where you go, but create one for one machine and one service. So I have, for this laptop, the secret key I use for GitHub. I have a different key to log into the CTAO GitLab, and on my home PC, I again have a different key for both of these services. And here's a command to create a new key following current best practices. So this ecliptic curve cryptography, not too important here, but this is the current best practice. And then you insert maybe your username and your machine name and store it in a specific file. And what you get are two files. I mean, we can do it now. So I do SSH keygen, call it demo, and give a comment, GitHub demo SSH key S3 school 2026. Then it asks me for the password. If you know you are on a secure machine that only you have access to, it's also okay to leave this unprotected with a password. If you are on a shared server, of course, you need to protect it with a password. I will just, for this demo now, will leave it empty. And then what it does is create a pair of files. And it says even here, your public key has been saved in this file here. And what you need to do is to copy the content of this public key file. Oops. Yeah, so this prints this public key. And then we go to your GitHub profile settings. And then there's SSH and GPG keys. And you can add a new SSH key and you just paste, oh, not the name, but the content of the file. So really this. It's because I'm in Tmux. Let me go into, sorry. This one. And now I can copy. Yeah, so it looks like this. You can give the title, or you can leave it open. And if you leave it open, then it will use the comment to create this. The comment here doesn't really matter. All that it's important is this cryptographic hash here in front. And if you configure this, you can use the SSH to log in. I won't do this now. I have my stuff already configured. And then the only thing you need to do is you need to, instead of the HTTPS URL, you use the slightly different format of the URL for SSH. And if you already cloned it with HTTPS and you want to change it, you can use this command here, git remote set URL origin, and update the link. And if you go to a repository on GitHub, for example, the S3 school repository, you always have the choice here between the two URLs, right? You can just select HTTPS or SSH, or just use this GitHub specific command line tool to clone the repo. All three of them work. But the HTTPS and SSH are not specific to GitHub. They also work with GitLab and Codeberg and your own ForgeJo instance or your own GitLab. Okay. Yeah, we discussed this already a bit, the concept of pull and merge requests. So this is the same, it's just different terminology. GitHub says pull request, GitLab says merge request. It comes from the same idea. So you request that the maintainer pulls your branch into the main branch or merges the main branch with your branch. It's really the same concept. And this means you are proposing a change to the software. You have your branch with changes with respect to the main branch. And how this looks like, maybe I can just show an example here from our software, maybe. Maybe one we recently merged. Maybe this bug fix here. So You see here the basic Git information. So Carl, again, we will do the lecture tomorrow, noticed the bug. He opened an issue. We discussed who should implement it. He said, I'm fine to do it. And now he has a branch called fix shower reuse, and he wants to merge that into main. And now you see, because it's already merged, you see that I merged it sometime later. And what he can do is he describes the description where he, for example, links to the original issue. So here's an issue which is now closed because we fixed it, right, with a description of what goes wrong. And then you can see here that I looked at these changes and I made a slight suggestion how this could be solved better. Carl agreed, we committed the update, and in the end, we were happy, so I approved this merge request, and the original reporter of the bug also approved this merge request, and then we merged it, and our software, the main branch, was updated. And this is a very large, important software project, or not very large, but large-ish. So we have the rule that before we merge a pull request, 2 developers of the main team have to agree. So 2 developers take a look at the proposed changes, and if they agree, the merge request is merged. Yeah.
Sometimes you see to ask for changes, and they say, open a pull request to do this, but don't you need to change the code to open a pull request?
Yes, but many things nowadays can just be done in the GitHub web interface, and under the hood it will create a branch for you. It opens an editor in the web interface, and it does the same operation as we would do on your own machine in your own terminal, but just in the nice web interface. It creates the editor, it commits the branch, and then opens the pull request all in one go. For many simple edits, you don't have to leave the web interface. You can change text and update the repositories just from the web interface without using Git on the command line.
Also, you have the issues you can open.
Exactly, yeah. And so what you saw now is that these pull requests are the main point where you do code review, right? The maintainers of the software take a look at your changes and give you feedback and iterate on the changes until they are happy. But also at this point, we run our tests to check if with the changes you are proposing, you don't break anything else, right? And what you can see here, for example, is we have static analysis, so a service that checks your changes with a certain set of software quality rules. It computes test coverage, which is something which we will cover tomorrow. And you can see here, we have a number of checks with different Python versions and different other software versions, and all of them were passing. So Vincent showed you how Pixie can manage these different environments for different Python versions. Very similarly here, we run the tests for Python 3.12, 3.13, 3.14 on Linux, on macOS, on all the platforms we want to support. Yeah. And I can't stress this enough. I think code reviews are really the most important part of software development. It is the basic quality control. It's very similar actually to the peer review process in science in general, right? You ask your peers for feedback on what you worked on. And especially if you are junior to the maintainers of a large software project, you can learn immensely by the feedback you receive from the maintainers of these large software projects on what you can improve on, where you need to learn more, if something was good or not. People will have a very deep knowledge of their software projects that you, if you just make a small fix, maybe can't estimate the consequences of this change. And this is really a good chance to learn. And this is the basic entity of quality performance documentation, the clarity of the software. And I didn't update this slide, but now I would say, if you are using the AI tools you will learn on Friday, the first step is you doing the code review for the code that the AI wrote, right? You need to understand the code that the AI wrote for you. You need to review it. You need to iterate with it to improve the code before you send this pull request to me as a busy software maintainer of a large software project, please don't send me AI-generated code that you never even looked at yourself. Yeah? Then I will just close your merge request and say, come back when you check this yourself and have done the minimal work to make this a proper contribution to the software. It's getting really problematic for a large number of popular open source projects. We see these drive-by merge requests where somebody just said, here is an issue number to Claude or ChatGPT, and they start trying to do something on this, generate code, and yeah, it at least at the moment still more often than not doesn't work out well and needs more iteration. For somebody experienced with the software or with the field, expert knowledge, and somebody used to making these code reviews, it's an immensely helpful tool. You can create software much faster than before, but you really need to be in this mindset of reviewing the code that the AI writes, iterating with it, checking that it's correct, that it did your instructions or transformed your instructions into the proper code. And for this, you need the domain knowledge, and you need to have this mindset of reviewing the software, the changes this AI proposed. And in the end, at least I am of the opinion that the AI isn't responsible for anything. If you open a merge request with code, it's your responsibility independently of you handwriting this code or using any AI model, I don't care. What you did, you need to take the responsibility for the code you propose for a large project, and you need to take the responsibility in this radical collaboration framework, right, for the changes you propose.
And for code review, if you are alone on a project and you don't have a reviewer, is it possible to use AI in this case?
Yeah. So GitHub, for example, has its own model. It's called GitHub Copilot. And if you have a license for this GitHub Copilot, it actually acts like a human reviewer. It starts making comments in your pull request. So if you open in the project where you are alone, you open a pull request, you would get review comments from this AI bot. That's also very useful, I would say. Yeah. And it's really smart. I the first time I saw this, I was like, oh, I didn't ask for this. Why is this here, right? I didn't agree to this because I maintain a project, and then somebody contributed who had a license for this tool. And that means even I, who didn't have a license at that point, in that pull request, the bot was making comments because the author of the pull request had the license. But it actually found an issue. I can show you the let me see if I find this quickly. I think it was this one. Yes. Where is it? So it says, here, look, you added a new data field definition. It has unit degrees, but I noticed that the similarly named field in your other definition has unit radians. That's inconsistent. Please double check the units. And it was right. It was a mistake. It wasn't degrees, it was radians. Yeah. So yes, even if you are alone, these kinds of review tools can be very helpful. Yeah.
There is only Copilot, or there is other tools?
There are many other tools. Copilot is GitHub's own, which is well integrated with GitHub itself. But GitLab also has its AI integration. You can connect it to models you self-host if you have a self-hosted GitLab. There are many of these tools. Yeah. Okay. It's the current hype, so there's more than one. Okay, so let's talk a bit about how to review code. And as always, automatize everything that can be automatized, so the humans can focus on the review only they can do with their domain knowledge, their expertise, right? You should have static code checks. So for example, in C++, that would mean you check if the code actually compiles. That's the easiest check you can do for a compiled language, right? Just compile it and see if it works. Then the next layer is unit tests. And for Python, there's also analysis tools that don't compile, but they check the syntax, the basic syntax level of the Python code, if it's correct or not. Then the next layer of things is the unit tests, and these should be executed automatically during your pull request, and then you see immediately in this interface if everything is fine. Then you still need to review, because it might have been that the person changed the tests, and then you need to check if you agree also with how the tests were changed, right? You cannot just rely on a green CI if the person also edited the unit tests. And then there's other automated tools for following specific code style guides. I don't know have we mentioned these yesterday? I don't think so, right? So there's, for example, the rough tool, which is an automated formatter for Python code. And I really like these tools because they put an end to the endless discussions about whether the brace should go on the next line or in this line or how many spaces or whatever. You call the auto formatter and the result is static, right? It's not a human deciding how the code is printed. It looks nice. There are static rules how the code should look like. You agree once on the configuration for these tools, and then everything is auto-formatted and is following the style guide. And that leaves you as a human being to check things that either just an AI or you can check. And this is, are there enough unit tests for the changes that are proposed? Is the code itself clear? Does it really address the issues? Are there any obvious performance improvements? Is the new code, the new functionality that was added, is it properly documented? These are the main things, I would say. And then maybe as an yesterday there was this framework, I think that said basically everything. I would say stay friendly but be concise, right? Don't fall into this maybe American communication pattern where you first say like a nice greeting for every comment you make, but really say, okay, this line should maybe be changed because of this. It adds a lot of unnecessary noise if you write large text in these merge request windows. So friendly but concise. And then, if you talk about performance issues, always keep in mind that Donald Knuth said that premature optimization is the root of all evil. So if it's really bad, say something, but if it solves the issue, the task, but maybe there's some optimizations you can do, maybe the idea is to get the feature in, have it tested, and then improve the performance with having the bedrock of the unit test that check that while you are doing the optimizations, you still give the right answers. Okay. And now I said that all of these popular open source projects are nowadays developed in Git and most of them on GitHub. But that doesn't really help you if you want to make changes, because if you try to clone matplotlib from GitHub, matplotlib, you change something and you push, it will just say permission denied, because you don't have a right to push to the matplotlib repository. And that's good, right? The maintainers don't want any random person to be able to push to their repository. But what really then enables this collaboration is that even if you don't have access to the main repository, you can copy it to your namespace where you can do anything you want. And this is called forking. And then GitHub has the feature that you can propose a merge request even from a forked repository. So you work on your version of matplotlib, which from me would be max0 matplotlib. I make the changes, but then when I open a pull request, I can open it against the main matplotlib repository, not against my main branch. And that is really the core functionality of GitHub that enables these massive projects with large numbers of collaborators to collaborate on these projects efficiently. Yes. So now next exercise, how we do this. So we need to clone the school repository, this pcoffee, right? And if you want to propose changes to it, we don't add you to our organization, right? You don't have permission to change something in the repository itself, only the teachers have. Because you would, for example, also be able to see the private repo with our solutions, which we don't want to show you yet. So what you need to do is you need to go to GitHub and click the fork button, and this will copy the repository to your namespace. So for me, it would be, again, Max Coffee. And then you have to deal with the a bit unfortunate situation that you now have two repositories you need to keep track of, the main repository and your copy. And how we do this is that we add the second repository also as a remote, and we can fetch from both our repository and we can fetch from the main upstream repository. And this name upstream is convention. So if you fork the repository, origin should point to your fork and upstream should point to the main repository of the software. So let's do this. Not this one. This one. And there's a big fork button here. And I click it. It asks me to which namespace. If you have multiple namespaces, if you are part of an organization, you can also clone it to somewhere else. But I mean, your personal namespace should be the default. You can rename it if you want. So sometimes if you have a large project that is organized in its own organization, they don't use unique names. So for example, we are part of the Rusio software, and they have their own Rusio, their own repository for their Docker containers. But it's not called Rusio Docker containers, it's called Rusio/containers. So if you already have a repo with containers, the name would conflict, right? So you could also say pcoffee fork or my pcoffee or S3 pcoffee, whatever. Yeah, you could rename the repo. It would still be connected to the original one. But in this case, the name is unique, at least for me. I don't have a pcoffee already. And then a good idea most of the time is to clone the main branch only and propose your own changes. So I can fork it now. I didn't do it before. And then you are now at the homepage of your fork, which is my namespace and the repository, and it even says that it's connected to this other repository in the school organization. And now you can go here again, you clone, and I use the SSH link. Depending on your setup, you can use the HTTPS or SSH link or the GitHub interface. We clone it, and then we go into it. And if we look at the remotes, we have one, the origin, which points to my fork. And what we can do is we add another one, upstream, git at github.com, S3 school p coffee. Now we have two. But we didn't download anything yet. We just configured it. So we can do git fetch. This will download from the default remote, which is origin. And if we give the name explicitly, it will fetch from also the school repository. And alternatively, you could do -- all, and then it will just fetch from all of them.
In that case, what do you know on which branch? No, there are no branches there. There are just two, because you fetch.
Fetching will download all of the branches that are available. It doesn't integrate anything yet, it doesn't merge anything, but it will download all of the branches from the repository, from the remote to your local machine in the Git directory. You can see all of the branches. So if you do git branch, it will list, git branch. It will list which branches you have locally that you worked on. But there are always also the branches on the remotes. And these are the current versions of the server repositories that you have downloaded already. And then what git pull does, it first fetches and then it merges the origin main with your local main. Okay. And now the rule about not changing anything on main becomes even stricter, because you really, really don't want to modify the main branch of a fork, because it will diverge from the main branch of the main repository, the upstream repository. So if you want to change something, you should always create a new branch, and you start from the current version of the main branch to be the most up-to-date that you can be. So if you want to start a new work, you git fetch the upstream, you create a new branch starting from the main branch of the upstream. And to enforce this, that you never can actually modify the branch, what you can do, and I discovered this only recently, it's a nice thing to do, is to run this here. This command here. And this will make that your local main branch doesn't follow your fork main branch, but it follows directly the upstream branch where you don't have access. So you just can't diverge. It will not enable you to diverge. This is not really necessary, but it really protects you from diverging your main branch from the other project. And if you do git pull now, it will git pull from the upstream into the main, so you are automatically up to date with the upstream.
You can configure also the Git to not to commit on the main branch. It's also an option, I guess.
If I would commit now here, it would commit on my local main branch, and if I would push, it would try to push to upstream, and then it gets permission denied.
Another solution would be to enforce Git not to commit anything in the main branch except by merging.
Yes, I'm not sure if you can do this locally. I think you can, but what you can do is you forbid this on GitHub. There is a setting to forbid pushes to the main branch, which are not merges. Yeah. Okay. Then issue tracking, just to mention one of these project tools, is very helpful for organizing. So users can report bugs. You with your other developers can plan the next developments. Issues have assignees, so you can say, okay, we discussed in a meeting that you should do this job, then you assign a person to this issue. And the issues can be linked to commits and pull requests. So there's a magic way how you can say that this commit fixes a specific issue. So if you have a commit where you include this magic fixes #42 and you merge this commit into main, GitHub will say, oh, issue 42 is fixed now, and close the issue automatically once this commit is merged. That's a nice little magic for this issue tracking. And similarly, you can also include this not in the commit message, but in the description of a pull request, and then it will also connect the merging of the pull request to closing the issue.
Should the issue should be already present into the GitHub or GitLab repository first? And the name should be the same, right?
The number is the number of the issue, and you only get it if the issue exists, right? The system assigns you a new number.
Okay.
But some projects really have the policy that they don't allow merge requests for things that have not been an issue before. Yeah. So they have, for example, in their documentation, they have a section on how to contribute to the project, and maybe it says, before you do anything, open an issue to discuss, and if you agree how it should be done, then you start working and you open the merge request. But this is more how different projects are organized, and it gets stricter the larger the projects are, the more of these rules they will have to optimize how they develop the software. We have a full lecture on continuous integration tomorrow, but just the basic gist is that you have a server that automatically runs your unit test and sees if the changes you are proposing still work. And these are run for each of the pushes you do, and especially in merge requests. And one specific distinction is that if you have merge requests, you should check that your CI system doesn't just run on the branch you are merging, but on the merged result. Because there might be merge conflicts, and there are merge conflicts that Git will just see, right? That directly conflict because you edited the same lines, and then it will fail. But there can also be semantic merge conflicts where Git is happy to merge the two changes together, but in combination they break your software. And this is very important then, that the CI system doesn't just run the unit tests on your branch, but first merges and then runs the tests, so that you can be sure that the result of merging the merge request is actually fine. And at least GitLab by default doesn't do this, and I think you need the professional license to even do this in the GitLab CI, which is unfortunate. GitHub does this. So if your GitHub merge request builds, they don't run on the branch, they run on the merged result of the merge request. Okay. Yeah, I think I will skip this because we have the full lecture on CI tomorrow. Yes. So this would be a good point again for general questions before we go into the last section of the lecture about some more advanced features of Git.
Is there any specific advice you would make about creating the name of a branch?
Again, there's projects that have very strict conventions. The larger the projects go, I mentioned this Rusio project. They, for example, have the rule that all of the branches, you need to create an issue first, and then the branch name must start with the issue number and then a short description of what you are doing. There are other conventions, for example, that you start all the branches you are working on with your username and then a short description to make clear that it's you working on this branch. But I would just, in smaller projects, just use small descriptive names of what you are trying to achieve in this branch, and that should be fine. The larger the projects get, or if you need some kind of automated reporting about what issues were solved, what pull requests were merged, and having these conventions for branch names or issue names and descriptions makes sense.
Related topic. If maybe you get an old project which has a lot of branches and you want to clean up, but without losing things, is there a standard or best practice for moving the old branches somewhere where you don't get to download it every time? Or is it too advanced, or maybe?
No. It's a good topic, but there is no good answer, because again, you can't really tell if there's something important in this branch without checking it out and looking at it, right? I mean, if you go into the GitHub web interface for the repositories, it might give you a very good idea just by looking at this interface, because, for example, it will just directly show you branches that haven't been updated in a long time and are far behind the default branch. So if we go, where is it? Branches? Where's the branches?
I think to the left, where it says main.
No, here, yes, I have to click here. So there's the default branch, there's branches I have been working on, then there's active branches which have been updated recently, but there's also this section on stale branches, which are all the ones that, for example, haven't been updated in 6 years, right? And maybe it would be a good idea to just delete them. This one, for example, I can delete because apparently it was merged in a pull request. We just forgot to delete it after we merged the pull request. So here I can just see those I can delete immediately. A bit more unclear are those here where I created a pull request, but we closed it without merging it. And then the question is, what is in there? Is it still interesting? Should I update it? Should I retry? Or can I just remove it and it was a bad idea and I can just throw it away? But in the end, it's about you deciding what you can throw away, and you can only do this by looking at what you have, right?
But for example, even if I don't know, can I do a archive repository, move everything there?
Oh, sure, you could push the branches to another repository, another location, and clean it up from the public view, maybe. Okay. Yeah, you can do that, absolutely. Okay, and I think now we are going into this section of random things that I think are useful to have. And many of them address questions where I said this comes later. So the first thing I want to show you is git add -p. And the p is for partial. And it is when you have edited a file, the same file, but now you only want to add a part of what you changed to the next commit. So you have maybe 2 or 3 locations in the file you have changed, but maybe we want to commit each of these changes individually.
Max, I just have a question
Yeah.
for the things before. I didn't understand how, when you put the number of the issue in the commit message, how the issue is closed, but the branch is not merged.
Now, when the branch is merged into main,
Yeah.
GitHub sees, oh, this commit message contains this magic keyword, right? Fixes
Okay.
something. And
So when it's merged.
Yeah.
Okay.
okay, so let's see. What to do next? Or maybe we document the fips function. So this is one change. And then we could maybe make our command line interface a bit fancier by using the standard library to create command line interfaces. We say we have one argument called n, and it's of type int. And then here we can just say we want to parse our arguments. We don't need to convert, we just say args n. And what this gives us, for example, I don't know if you used this before, but we now, for example, get a help method for free. And we can run it, and because we set type equals int, we don't need to convert manually from string, and we can just use it. So now if we look at git diff, we have 2 basically completely unrelated changes, right? This nicer command line interface and the documentation. And what we now can do is we run git add -p, and this splits now the changes into sections, and we can say we want to add this, or we don't want to add this, or we would even want to edit this change. And let's do the command line argument changes first. So this is only command line argument changes. So I say, yes, I want to add this. This is a good example now, because now it mixes the changes, right? It has, in this next section, it asks me about the change to the documentation and also about the change to the command line interface. So what I can do is I can ask it if it can make it smaller. And now it just asks me about the documentation change. I say no, because I want to only add the command line argument changes. And then I have the command line argument changes, and I say yes again. And now I'm through. I have edited all of these changes. And if I now look at git diff -staged, it's only the changes for the command line interface that would go into the next commit. And if I look at git status, I'm in a bit weird situation that I have changes to be committed for fib, but also untracked changes for fib, right? And git diff shows the documentation change that's not added yet. Git diff -staged. Remember, git diff -staged always shows what ends up in the next commit. Is only the command line changes. So I commit, use argparse for CLI. And then the remaining difference is the documentation change. I can just git add the full file, because now I have only the one change remaining. Okay, so this is git add -p. If you have a longer work session, you forget to commit, you change multiple things, this is extremely helpful. I use this very, very often. So this was the question about Git bisect, right? And Git bisect is a tool for debugging most of the time, and allows you to make a binary search for the commit that changed something. And the idea is you know a version that was good, and you know a version that is bad, and then you want to find the first version that is bad. So I have an example here for this AstroPy issue. AstroPy, as part of its library, has a unit system, and you can compute with NumPy with degrees or radians, and because of the magic in the background, it will just do the right unit transformations. And we noticed that in a release candidate for a new version, something that should have been a neutral unit, so no unit at all, the result of a trigonometric computation, suddenly created an error when we used it in a multiplication. So something broke. That wasn't covered by their unit tests. Very specific issue. Hard to figure out in the, 10,000 commits between the first version, the last version that was released, and the next release candidate. And now we can look into how Git bisect might be able to investigate this issue. So I go to my AstroPy, which is here. And I'm on the current main branch. And I can see, for example, this v7.2.0 rc1 is this tag where they updated the final changes before they made the release, is updating all the contributor statistics and this release. And I mean, if I want to check what happened between v011, v711 to this, and maybe at the one-line option, there's a lot of things here. Let's count how many. Yes, so it's not 10,000, but 1,057 commits between those two versions, right? So manually now figuring out which commit is the one that broke it to investigate what could be the fix is very tedious, right? So let's make an example that tells us if the version of the software is correct or not. So a very simple example that shows us if this still worked is, I think, this. And we need NumPy. And we just create like a random NumPy array. 1, 2, 3, 4. And this doesn't have any units, right? This is just a NumPy array. And what worked before was multiplying this NumPy array by a constant that had an AstroPy unit, but the unit was the identity unit, so also actually no unit. So maybe the constant is 5 times 1. But now the magic for this issue was that because we did computations, it was actually the inverse identity unit, which is also the identity unit. But that's exactly what it turned out was the issue was about. So now if we did this multiplication in place, it would complain. So let's do this. So I install AstroPy in development mode. I'm sorry for not using Pixie here, but for this project, I'm not being used to using Pixie. I use UV directly. But for this demonstration of Git, I don't think it's important. If it finishes, if I have enough network, maybe. Yeah, fine, okay. Activate the environment. And now I'm on the main branch where it was fixed. So if I run this, no, actually I am at a point where it fails, right? So this is an exception, and this worked before. So if I go to this version v711, I'm now at version v711, git status, right? Had detached at v711. Oh, I have to pip install -e again. Never do live demo. This worked yesterday. AstroPy has some C modules that need to be compiled, and apparently I missed one of them in the checkout. Okay. Oh, and the old version is not compatible with the newest NumPy. That's an issue I ran into yesterday night. Okay, NumPy 2.2 should be fine. Okay, let's try again. Oh, I'm trying to multiply an integer with a float in place, which doesn't work. I need to use floats here. Okay, but now it works. No error, right? Version 7.11, no error for this code. And then the release candidate for the 7.2 version had a bug where I get this error, cannot store quantity with dimension, blah, 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 blah. So I have a commit that works, I have a newer commit that doesn't work, and now I want to find what broke it. And what I can do is git bisect init, start. And that tells Git, I want to now search for a commit, and then I can say, okay, I know that version 7.1.1 is good, and I know that version 7.7.0 RC1 is bad. And what it does now is starting a binary search, and it put me basically in the middle commit between the two changes. And now I can run my test again, no error. So what I do is git bisect good. It tells Git that this commit was still good. And then it goes to the next step. And it tells me even we need 9 steps more. Yeah, it's a large project, lots of commits, but we can be fast here. So this is an error, so I say bad. This is an error, so it's bad again. This is an error, so it's bad again. This is an error, so it's bad again. This is no error, so it's good. No error, good. 3 steps to go. No error, good. No error, good. Broken, bad, and now we should be done. Yes. So the commit that broke it was a commit that had the message rewrite quantity multiplication. And I'm like, yes, this looks like really the issue, right? Somebody optimized how AstroPy units internally handles these multiplications, and apparently they introduced a bug, right? And maybe you are impressed now that we found it this fast, but you can even be faster. So you do git bisect reset, I think. Okay, now we are back at the good revision, right? And what I can do is git bisect start, and then I just give it, I think, the good first and then the bad. So bisect start, no, bad first, then good. So bad is 720 RC1 and good is 711. Oh, I missed the start. Okay. And now I can, because I have a script that errors if it's bad and succeeds if it's good, I can just say git bisect run Python test, and it just does it automatically. And I'm at the commit that broke it. That's a really powerful debugging tool to understand the history of large projects. If you can write a unit test or a simple test that reproduces the bug, git bisect will just find you the commit that introduced the bug.
Is it running only on DAG?
No, on every commit. Any commit that is reachable between the good and the bad, it will test. Yeah, it leaves you at this commit. If I now, it leaves you checked out the commit that broke it. And you can look around. If I do not git show now, it's exactly the commit that it identified.
So you workflow then you create a branch from the last version?
It depends, yes. This helps me identify what the issue is, and then I need to discuss with the maintainers what the best fix would be for this issue, because there was a change, it was made for a reason, but it had an unintended side effect, and we need to somehow fix the issue. Yeah. They directly said, yes, this is a correct issue, we need to fix it, but we prefer to not just revert to the version before, because the change was made for a reason. We want to fix the new version of the code to also cover this side effect. Okay, and now we go into one of the questions from you, changing the Git history. What is the difference between merging and rebasing, and how you do this? The first simple example, first the legal business. Disclaimers. We are now showing you commands that will modify commits in your Git history after they have already been made. And this is dangerous because if you share and collaborate on a project, just changing the history of your main branch, for example, will make it hard to impossible for the other people to integrate their work. Because you will see that, for example, if you want to create a merge conflict, Git will complain that there is no common ancestor anymore. If you rewrote all of the history of your project, somebody who worked on a different branch, the commits don't work together anymore. They can't simply open a merge request. So the rule is never really modify the main branch of your project. There's two situations where this is semi-often done. So you might have committed by accident sensitive information that you want to clean from your Git history. Or you have, we talked about this before, right? Git is not good for storing large binary files. You realize you have some of these in the history. You don't need all these revisions anymore, you think, at least. You can get the data from somewhere else, or it's really obsolete files, and you want to clean up the size of your repository by removing these old files from the Git history. These are the only, I would say, semi-valid use cases for rewriting the history of the main branch, and this needs to be done with extreme caution, for example, by having a meeting together with all of the main developers, agreeing on the time when you do this and on the execution, making a backup before of the old version, and so on. And for sensitive data, I would say if it's just passwords, please leave them in, change the passwords. If it's really sensitive data like medical data you committed by accident, then you of course need to really clean them. You can't change the data, right? But the most common case for this is you have a configuration file with a password to access some service. You committed this by accident because the file was not ignored by the git ignore. And then please just change the password, revoke the token, and don't try to rewrite your Git history. So having this out of the way, for things that you haven't yet pushed or that are in your feature branch, I would say it's completely fine to change the history. And for large projects, it's often even asked. So if you work on a complicated feature, you try out different solutions, you have a pull request that in the end does a relatively simple change, but you needed 50 commits to end up at the correct solution, then the maintainer will see, look, the change is fine, but we don't need this 50 commits of trial and error in our Git history on the main branch. Please change your history so that we only add your final solution to our repo and not all your intermediate steps. Sometimes the history is important, but sometimes it's also just noise. And tomorrow in the CI lecture, you will see that configuring the CI system is often a case of trial and error. You change the config, you push, you wait 5 minutes until the CI runs through, you realize you made a simple mistake, you change the configuration, you push again. And this kind of change, when it works, then you squash all of these commits together in one change, call it add correct CI configuration, and then you are happy, right? Yes. And then if this is the case, if you have projects where you regularly change the history, please enforce in the settings that this doesn't happen on the main branch. So there are branch protection settings in GitHub and GitLab, so that if somebody tries to push with a rewritten history which needs this -- force option, it will just deny it if it's targeting the main branch. And that should be activated, I think, for any repository. And that's also there you can not only forbid force pushes, but any pushes. So you can forbid all people, even the maintainers, from pushing directly to main, and this will be then the situation where only the merge requests can change actually the code in main. And this is, I think, the recommended approach. What I do most often is this. So I have something like this. Oh, we realized, right, we did a proper CI now, so we can do fib.py 5, and that's 5. And then I commit -m, oh no, I add first. And then I commit, and I'm in a hurry, and I do update readme, and then I realize, oh, damn, I made a typo in the commit message. And for this, it's git commit -- amend, and it reopens the editor. I can edit the commit message, and please observe the hash. So now it is at 2BAF and some more numbers. And now when I store this, Git will overwrite this commit with the fixed message and the hash changes, right? So I really changed the history. The old commit is gone. Then it's a new commit. It has the fixed message, but the hash completely changed. It's a completely different commit, so to say. And if I have nothing in the staging area, git commit -- amend will just edit the commit message. But if you add something to the staging area, it will also be added to this commit. So anything that you have in the staging area and anything you change in the editor, when you do git commit -- amend, instead of creating a new commit, it will modify the last commit you did. This is, by the way, also helpful. If you realize you have a typo or something unwanted in your authorship information. So now I use my short name, but in official contexts, I like to use my full name. But anyway, so let's add something here. So 6 should be 8, right? And now you see that this commit was made with the shorter name, and then maybe I realize later. And what I can do is fix the configuration. And by default, git commit -- amend doesn't do it, but I can ask it to reset the author. And also this will change the commit hash. So again, the authorship information is part of the information that Git uses to identify a commit. If I change it, the history will be changed. Okay, and then we go to the differences between rebasing and merging. So rebasing means if you start a new branch, it will start from the one commit at the moment you started the new branch and you add them to this new branch. But in the meantime, there could be new commits on the main branch. And rebasing means you basically plug off your changes and try to apply them on the main branch one by one. So not merging, but really saying, okay, I did these relative changes, but instead of applying them on the branch or on the commit I started from, I now try to apply them to the most recent commit of the main branch. I think I have some graphics here shortly to explain this better, but okay, so the default of git pull is to merge. So git pull is equivalent to git fetch and then git merge the remote branch into your local branch. But you can also do git pull ---- rebase, and this will then fetch and rebase. And this will first take the history like it is on the remote branch and then again apply the commits you have in addition locally on top of this. And this might also need the resolution of merge conflicts, and not just once, but for any commit that you add that doesn't work with the previous commits. So it's a bit more involved if you have merge conflicts. But it results in a much nicer history that's easier to understand and, for example, easier to use with git bisect. So that's why maintainers of large software projects will tell you, please rebase this merge request on the latest main so that the history looks nice when we merge it and we don't, and we can easily identify issues, for example. Yes. And you can change the default of git pull to be rebase using this command I show here. I do this. It's a personal choice, up to you. I like the rebase by default. Yes, and here's the graphics. So imagine we are in this situation here. We started our feature branch from commit B. We added 2 more of them on the right side on our branch. And in the meantime, C, D, and E were added on the main branch. And now we want to update our merge requests so that this tests run on the most recent versions. We can discuss the changes, etc., etc. And what this means now is if you would do this with merges, you have to first merge the main back into your branch. So you merge maybe the E commit into 3 to update your own branch. And then the maintainer said, okay, this is fine. Only one commit difference is fine. We merge your branch into the main branch, and this creates the F commit. So you end up in a situation where you have 2 merges. One is going from the main into your feature branch, and then the feature branch goes back into main. And this is a bit ugly, right? This looks a bit complicated.
Excuse me.
Yeah.
I don't understand the arrow from 2 to D.
So the arrows always point to parents, right? So the 3 command has 2 parents, which means it's a merge commit of the main when it was at D, and the 2 commit when it was on our branch into our branch. Good question. Exactly. And the idea is that if we rebase, we take the 1 and the 2 commit, we take it away from our branch, we apply all of the changes that were in the main, so we go up to E, and then we try to apply our 2 commits back onto the main branch. So the ideal situation after we rebased is the main is up to date at E, and we basically are up to date with the main, but we added our two commits. And this works by first removing our commits, then updating with the main, and then trying one by one to add the commits back onto the main branch. And then the pull request can be merged, and you have a very linear history. You have the main branch, you have our feature branch branching off and being merged back into the main branch. And this is much easier to debug using Git bisect, for example, than if you have these complicated back and forth merges. So this is why maintainers of big projects will maybe ask you to rebase or squash commits and change the history. Okay. And then there is also interactive rebase, and this is an extremely powerful tool. I can show you a couple of things what you can do here. So what I could, for example, do is I rebase interactively as this with just like 4 commits before. And then it gives me an editor, and it shows me the 4 commits that were made last. And now I can edit this first column with a couple of magic commands. And by default, it would just stay the same. It picks the first commit, the second commit, the third commit, and the history would basically be the same. But I can do a couple of things. For example, I could say, okay, I'm not happy with the commit message of the second commit. I want to revert it. Or I can even change the order of the commits. I think it makes more sense to have the commits in this order than the other order. Or I have a bug fix, or I made a change. I will show this maybe later as an example. And then I could even combine 2 commits into one in the middle of the history. And like this, we would reorder the history, and we would change the commit message for this commit here. And I could even say, oh, this example is completely superfluous. I just want to drop this commit. I want to delete it. Okay, and if I do this, this is now the one where I said I want to revert, right? So add docstring for fibs at the function. Doesn't matter, it's a stupid example. And now I'm finished, and you see the one commit about the example, it's dropped, the order of the commits changed, and the update was done for the README. But my main use case for this is, again, if I notice something should be fixed, and it's not in the last commit, so I cannot use git commit minus amend, I make a small fix command, and then I combine them. So let us invent a situation where this might be useful. Maybe I say I want to have a generator function and not a list, because we don't want to accumulate all the storage for the full range of numbers, right? You can do fib I for I in range n. And maybe my logic should be generate up to the nth Fibonacci number. And now my documentation and my code don't match, right? Because I don't generate up to the nth number, I generate n numbers, so I have an off by 1 fence post kind of bug here. Sorry. So if you have the square brackets, it creates a list. And that allocates all of the memory for the 10,000 Fibonacci numbers I want to compute. And the second one creates a generator expression. Now we are going into Python details, fine. It creates the numbers one by one as you iterate over the object that you get back from this function. So it doesn't allocate all the memory at once. It really is, as you loop over the values, the next one is computed. So if okay. So this won't print a number of a list of numbers. This just says, oh, this is a generator object.
So you access with next.
Exactly, yes. Or you can iterate with a for loop over the values. Yeah. And I could do, for example, okay, I commit this now. I already did. And then I changed the CLI to use this generator function. So for I in fibgen print I. And then I realized this prints 5 numbers and not up to the 5th number. But let me commit anyway. And now I realize my mistake. And I say the code is fine, it's consistent with the list, but we say generate n Fibonacci numbers. And now I introduced a buggy version of a code, right? Then I made an unrelated commit, and then I fixed it. And if I would have already published this, there's nothing to be done. But if I make a pull request, for example, there's no point in having the wrong version in the history of the Git project, right? So what I can do is git rebase -i back to this one before, 78BC. Add generator function, use fibgen for CLI, and fix the docstring. And what I now want to do is I want to integrate the fix into the initial introduction of the function. So I move this commit here. And now I say I don't actually want this. This is just a fix. And what Git will do if it sees something like this is it takes the changes of the first commit, and without modifying the commit message, it integrates the changes of the second commit into the first commit. And you will see on the left side, the fixed docstring will disappear, and all of the hashes of the 2 commits will change. And now if we look at this commit that introduced the function, git show, now it's 78BC, it already has the correct docstring. Rewriting history. Okay, yeah, then how much time is left? 9 minutes, that's good. Submodules, just quickly, is a way to add a Git repository, add a specific revision to your Git repository. So you just say git submodule add, you give the URL and the path inside of your repository where you want to have this. And then you have a fixed revision of that Git repository as part of your own Git repository. And this is sometimes useful to integrate several projects together. It's, for example, a common way to have the Google test framework into your C++ project. So the recommended way, or one of the common ways to have the Google test framework in your C++ project is to have it as a submodule in your C++ project at the specific revision you want to use. It's fixed for anyone checking out your project. It's getting compiled as part of your application, which is the recommended way to use it. And you can update it from time to time, and the updates themselves will be stored in the Git history. So your Git history has the pointer to the version of the Google test framework you are currently using inside of the Git history. If you clone the repository now, the submodule by default will not be checked out. There will be an empty directory for it. And to also clone the submodule, you either have to give it this option recurse into submodules, or after you cloned it, you need to run this update command to update them. I won't demonstrate this now. If you need this, I think you can figure it out with the documentation. Yeah, and I think that's it. Questions?
So questions?
I often use Git as backup solution. You know, I know that I'm going to travel, and I just want a backup, and it's not important version commit. So how can I think that it's squash You know, I don't need it commit. I have a commit, an important commit, and 5 or 10 backup, and I just want to erase that.
Yes, so there's 2 ways to do it. One is using this git rebase -i. So what I showed you before, this fix up was one way to combine the commits, right? So you could just say, if the last 5 now are your non-important backup commits, you could say git rebase -i to the one that you want to keep, maybe 5963. And then you say, okay, squash this one, squash this one, squash this one, and they would all be combined. Another way to do this, I will now completely empty this, so it aborts, right? Is to use reset. What you can do is git reset with the soft option, and you will reset to the last commit you want to keep unchanged. So maybe again BCD 09. And this removes all of the commits that follows it, and you have them back in the staging area. So now all of the changes that happened in the last 3, 4, 5 commits are back in the changing area, and you could make one commit now, or you could completely throw them away, or whatever you want. This is also a nice way if you have a merge request that has a long history and you don't want to keep it. You just reset soft to main, which leaves you just with the basic diff to the main branch, and then you can commit it in one commit. You have one commit that makes the changes you want to propose. And this is a very good chance for a foot gun, right? You might throw away work you actually need. So in this kind of situation, the git reflog command is very helpful. It shows you the jumps you made between different commits while you were editing. So for example, I see now I used git reset to jump to BCD 09, and before I was at 3DA 2. So what I could do now to revert this is git reset --hard 3DA 2E, and I'm back before this thing. So if you are toying with the Git history, make a backup, and if you mess something up, sometimes or often even the Git reflog, I should add it to the slides, can save you. Yeah.
Say make a backup, just copy the .git repository.
The whole directory. The whole directory just to another directory on your machine, or push the changes, right, and modify locally, and don't push again until you have verified that everything is fine.
Your local machine, you can copy the
copy -r the whole directory, it's fine. Everything is in this .git. If you copy the repo, it's there.
I have a specific question. If we done some modification and some unit test to check a function, for example, and when we merge this function to the main, if we don't want to add all test results, in the case that our test generates many subfiles, but we want to keep this result on a side in the case that we want to see them, there's a solution. What we should do for this case?
So you said a couple of things that I think are not generally understood to happen, right? You said your unit tests generate files, and that's a side effect and usually these would be just ignored by the git ignore. They are files that are produced. But now you said these are important, you want to look at them, right? So I wouldn't add them to the Git history, never. Okay. But there's a system, for example, in the CI systems, which are called artifacts. So your CI system runs, your test produces output files, or your build produces a package. And what these CI systems allow you, I don't know if Carl will tell this or talk about this tomorrow into details, is to specify as a last step to upload the result files to a server, for example. And then you can keep them not in the Git history, but upload it to some data server, to the GitHub data server for artifacts. You can download them for each specific run of the repository. For example, if we do this for reporting, so we have one job I will present this tomorrow, that computes which parts of your code were actually tested. So for every code line that was run, it stores, yes, this line was run, and then in the end you can check if all of your code is covered by the unit tests. And this generates a report, and we want to save this report to look at it later. So what this does, it uploads an artifact. This is the job which has coverage in the name. And you can see here there is one step that is upload artifact, and you can just click here to download the data. That's the solution I would choose for this kind of automatically produced files that are outputs of your code, not really something you store long-term in the software history.
And if you want to pipe or UV install something or Pixie install something that was located on the GitLab or GitHub repository, is it possible or not? Meaning like that you can have the latest.
Yes. No, there are several approaches to this. So first, pip or Pixie, they just support installing from URLs. So you can just give it the URL to the repository. If it's a valid Python project, they will download it automatically, and they will install the code they find.
But not the wheel or
No, the Git repository, the code.
Okay.
So for example, if I want to install the latest CT8 pipe version, I can do pip install git plus. Let's do a virtual env. And this tells pip, please use Git to check out this repository and install the Python package you find inside. This is the first version. You just install it once. You have a fixed version of it. It's the latest version it currently points to. The most common solution, if you actually want to develop, is to clone the repository locally and use pip install -e to install it locally in development mode and work like this.
Well, obviously, it's not a good practice to point to the latest version because
yes,
it's not.
For most purposes, you should use a fixed version in conjunction with these log files as provided by Pixie, for example. You let Pixie resolve all of the. I mean, I don't know if we have really spelled this out, but the log file is not just for your primary dependencies where you say, I use NumPy, I use matplotlib, but it will even then, after you specify that you want to use matplotlib, it will resolve all of the transitive dependencies, so the dependencies of matplotlib and the dependencies of the dependencies of the dependencies of matplotlib, and will find one set of versions for all of these packages that work together and freeze it. And so you only care about, I want to use matplotlib, but matplotlib has its own dependencies, and these could also break your code, so Pixie for you creates a fixed version for every package that's involved in getting matplotlib installed. And that's usually where it breaks. You said, I want to use matplotlib 3.10. Somebody else creates the same environment and they get matplotlib 3.10, but then they get a different version of one of the transitive dependencies and it breaks.